Alright, let's continue with binomial distributions. So the last part is we already looked at calculating probabilities for binomial distributions. Now an extension of it and the application is, instead of determining the probabilities, is to determine the sample size. So here, look at this question, pause the video, and then we'll go through this first example. Alright, so first determine that it is a binomial distribution. Now I always like to identify the random variable first, which is the number of shots that hit the target. Once you know that, you can determine your probability of success. Here in this situation, it's straightforward from the text. And then your unknown is going to be the minimum number of shots, and with a condition. The condition is to hit exactly the target 5 times. It means that x, the number of shots, needs to be 5, and that probability needs to be more than 0.25. What you do is you express your probability x equals 5 in terms of n, your number of trials, which that you have here. You make it as an inequation, so it needs to be greater than 0.25. It is an exponential inequation, so at the moment the issue that you have here is this is dependent on n, so is that exponential, which makes it a bit tricky to calculate by hand. So here you will just use the cas. Here we express our combination. We put in the cas as it is, so you use your solve function. You enter first, you solve the equation, okay, and that will give you the minimum value, which is the first one. So then you substitute into your inequation, so n has to be greater than that number. As it is a discrete value, the minimum value needs, the minimum number of shots will need to be 7. Alright, another example. Again, pause the video, have a read through, try to write down all the information that you will need for your from your binomial distribution. Okay, binomial distribution. They haven't defined the variable, so it's the x is the number of winning a prize. Okay, in this situation, it needs to be at least twice, which is that probability, so has to be greater or equal to 2, and that probability needs to be 0.95. Here we have the probability of success, and n will be your number of trials. Now, as x has to be greater or equal to 2, it implies that the number of trials has to be 2 as a minimum. Okay. Now, n is your number of trials. If you write your probability as x is greater or equal to 2, that includes x equals 2, x equals 3, up x equals 4, and so on up to n. But you don't know how many you have. The trick here is to use the complementary probability. So here, this probability plus its complementary is equal to 1. So we're going to do a substitution. Substitute this by 1 minus probability of that one. We rearrange it to make it the subject, and now that probability will be less than 0.05. this one, this probability, when x is less than 2, the lowest value is 0, and then the next one is 1. That gives you only 2 terms, which is easier to calculate. So here we have our 2 terms. Then you express those two using the binomial formula, which you have here. What is nice about this one is the coefficient will simplify here because you have a r of 0 and a r of 1. So you simplify your inequation. This one should simplify a bit more, which is this one. Yep. So that's a n coefficient. Again, yep. I think you will have to go with a CAS for this one. Definitely we'll solve it with a CAS. I'm just thinking of a way if it could be done by hand, but at this stage just CAS as it is. So again, when you CAS it, you will use the equation, so it's an equal sign. You will get two values. This one is negative, so it needs to be excluded. So what you would do is, knowing that the value has to be around here, to narrow it down is you re-evaluate the probability with the n value of 8 and 9, and you can see because of that percentage you can answer that question that it needs to be at least 9 times to be less than 0.05. That implies that the other probability, the complementary, will be greater than 0.95. And that's it for this exercise and the chapter, and I'll see you for the next chapter. I just can't remember which number it is. See ya.